this point, there you go. I'm going to record the session for those that can't make it. However, we won't see your names on the side. You'll just see me in the main window. At this point, you guys are muted, but reminder, at any point, you guys can unmute yourselves if you guys want to speak up. There's a way that you can actually raise your hand, and if you have a question, feel free to raise your hand or just speak up whenever you need. Garrett, you just raise your hand. You can unmute yourself and speak if you need to. Or not.
I was just demonstrating.
Oh, okay, thanks, Garrett. So right now I am going to share my screen. And when I share my screen, I just want to show you guys a PowerPoint that I created for this. So where's my PowerPoint? Here you go. So can you guys all see that? Okay, so
yes. Okay,
thanks. So here is welcome to Math Rocks. I created a YouTube channel with all the videos. You guys probably got the links already. So we're expected to go probably until 12:45 p.m. If any of you guys need to leave early or come in late, that's totally fine. Everything will be recorded. This is the agenda for today. We're gonna check in, give some time for any questions, some announcements. We're gonna work on the rationals of class worksheets, so make sure you have that prepared with you in front of you if you can possibly. It's on the or it's on Canvas if you need to print it out or take a look at it. I'll give a break sometime halfway between. I'll do a few student spotlights. We'll continue the class worksheet. For group 3, if you have your presentations ready, make sure you present today or Wednesday is fine as well. And then we'll conclude at around 12:45 approximately. So first thing I want to do is check in with everyone. So I'm going to practice putting you guys in groups right now. It's going to be random groups. And the question is going to be, what are your highs and lows from this week? It could be math related, Corona related, anything at all. So at this point, give me 1 second. So at this point, I am going to put you guys in groups. So I'm going to put you guys in groups of 3 people. It's going to be random. So go ahead and unmute yourselves with your groups. You guys should be in groups right now, I believe. Are you guys in groups yet? I think so, right? Oh, let me unmute you guys. So let me give you guys a chance to go ahead and chat with your groups. What are your highs and lows of this week? Introduce yourself.
What the hell just happened?
All right, everyone, welcome back. So that's what the break rooms are like. So each time we'll just do a little bit of a check-in with random people in our classes. But then I'll be doing that throughout the lecture as well. I'll put you guys into break rooms so that you guys can discuss anything that you guys need, right? And then when we go in break rooms, I encourage you guys to put the audio on or the visual on just so people can see you, so it feels more personable. But if you don't feel like it, that's fine as well. All right, so again, I'm going to turn on my screen sharing. So thank you for sharing your highs and lows. The announcements for this week, the homework is due this Thursday and also Sunday. So same thing, I'm trying to keep everything very similar to what we've been doing in the past. Thursday and Sunday homework is due. Our next ConferZoom is going to be on Wednesday at 1 o'clock. So I'm switching it between 10 o'clock or 1 o'clock based on the two classes. We do not have ConferZoom on Fridays. It's only on Mondays and Wednesdays. And that's why the sessions are a little bit longer than what we have in class. And make sure you print out this next time. We do have a quiz on Monday. So the quiz will be covering chapters, we'll be covering rationals. It will be an online quiz, and you'll have all day to do it on Monday. So it'll be one day, and it'll be open until midnight. So you take it whenever you can during that time. The practice exam will be open right after that. Practice exam is due on Tuesday night, and we'll have our first exam on Wednesday of next week, covering chapters 6 and 7 for Math 140, and chapters 4 and 5 for Math 130. So it's going to be an online exam. It'll be open up on Wednesday, and it'll be due by midnight. So, and also the SLA is due as well. So Garrett, do you know anything about the SLAs, how they can do that by any chance? Do you have any information on that? Garrett, can you speak or?
Thank you. Sorry, guys. I think they're still going to be doing it online. Everything's closed. Like you can't go to campus. Believe they're going to be trying to figure out workshops. You're going to have to make sure if you want to do a workshop, you have to, I think it's on the website. And then the DLAs is going to be similar. You're going to have to print it out, fill it out, kind of like you're doing with your notes right now. You'll print it out, fill it out, make sure you have it completely filled out. And then you'll get in like one of these conference calls with one of the tutors from the center. And I think you're gonna like email it to them or kind of just like hold it up and show them, and they'll go through it with you. But yeah, I don't know. What were the three? There's DLAs, workshops, and one other one.
And SLAs?
Well, SLA is like the collective group of them, but
Right.
then there's three types. There's DLA, workshop, and one other.
Directed studies or something, I'm not sure.
Yeah, I don't think they're gonna be doing those. I think it's just workshops and DLAs.
Oh, okay.
So either like with a group or just by yourself. I don't know if they're holding all three, but I'm pretty sure all that information is on the website if you go to the Mastic Center website.
Okay, great. Thank you. So have that turn in by Wednesday for the exam. And if you're really stressed and you can't get it done before then, I'd rather you study for your exam. So you can turn it in late to me if you want. I'm pretty flexible on the SLAs or DLAs. And Garrett, you want to talk about what you're providing?
Yeah, so it's similar to this. I feel like it's a little bit more user friendly because it's meant for higher volume. Some of you guys may be familiar with Discord, but if you use this link, did you send them out an email with?
No, I'm going to send it out after this. I want you to announce it first.
Perfect. So yeah, it'll be a link, and it's just like a chat room kind of thing. We can do video chat if you want me to like walk you through or explain anything, or you can just like upload your message. You can take a picture with your phone and upload it. It's an app on your phone that you can use, or on the computer, and you can just upload your picture or just type out your question, and from there I can answer it. And it'll be not through Friday, so I won't be doing Friday, but Monday through Thursday, noon to 4. And like during that time, I'll be actively on it, answering your questions immediately. Any other time, feel free to post it, and I may get back to you immediately. It may be like an hour or 2 hours later or sometime later. But during those times, I'll be sitting at my computer expecting people to come on. So please feel free to come on and ask questions.
All right. Great, thanks, Garrett. And I'll go ahead and make sure that I send this out to the class with the invite. So it's Monday to Thursday, 12 to 4, right?
Yeah.
Okay. All right, so today let's go ahead and talk about what we're going to be doing. This is going to be rationals part A. There's 19 topics. Again, due this Thursday. We're going to talk about rationals. So rationals is pretty difficult. So I just want to warn you guys that this is a pretty challenging topic because it deals with fractions, which is something that, you know, a lot of students struggle with. And this is where factoring comes out to play. So everything we learned in the previous chapter comes out to play in rationals. So if you did not know how to factor, it's going to be really, really hard for you to do this chapter. So make sure you understand factoring before you get here. And if you need help, again, there's the Math Success Center online, and there's Garrett, and then there's me online as well. So please make sure you know how to factor before doing this. These are the main topics, and this is how I broke it up that we'll be covering today. And I kind of like this this cartoon. Did you divide by 0 again? And his exam is like burning. Basically, when you have a fraction, you can't divide by 0. So that's the same thing with rationals. You can't have a 0 in the denominator. And this is what we're going to be doing tomorrow, on Wednesday. So I'll revisit that later. So I am going to, so I'm going to mute everyone right now. So does anyone have any questions, actually? Let me know if you guys have any questions on any topics or anything that we are covering.
Not yet.
Not yet? Okay. Okay, I'm going to mute you guys. And again, at any time, feel free to speak up and unmute yourself. Alrighty. And I'm going to start the lecture. Go ahead and take out your worksheet. You guys can all see my screen, right? Thumbs up, yes? You guys can all see my screen?
Yeah, we could.
Okay, good. Hi everyone, this is Professor Nancy Mahan. Today I'll be going over the topic of rationals. And if you haven't done so already, make sure you print out the lecture for chapter 7A in ConferZoom. And just note on Alex for Math 140 is chapter 7A, but for Math 130, it should be chapter 5A, I believe. So it's the same topic, just a different number based on the classes. And I'll be going over this worksheet today. There will be 19 topics that I'll be covering, and this is due on Thursday by midnight. So the first thing we want to go over is, what is a rational? Well, a rational is basically a complicated looking fraction where the numerator and the denominator have polynomials on it. And luckily, we just learned about polynomials last week. So polynomials have letters such as variables in them, and they also have exponents, and have adding, subtracting, and have terms in them. So there's a numerator and a denominator, and it's basically just a complicated looking fraction. So let me go over some of the rules of fractions, or review some fraction rules, and they'll apply to rationals as well. So like I mentioned, rationals are fractions with polynomials in the numerator and denominator. And if you just want to see what it looks like, if you look at our worksheet, these are all rationals here. They are fractions with polynomials in the numerator and the denominator. So they're fractions not just with the number 1/2 or 3/4, but they actually have a lot more going on, a lot more interesting things going on with exponents and variables and adding, subtracting, etc. So since we're talking about fractions, then let's review some of the rules of fractions, because polynomials follow those rules as well. So one of the number one rules of fractions, is that what can you not have in the denominator? you cannot have a 0 in the denominator, right? So can never have a 0 in the denominator. So if you forget about that rule, if you did 5 over 0, if you put that in your calculator, you'll end up getting an error, right? Or some type of message that says that this doesn't work. So 5 divided by 0, we call this undefined. So we can never ever divide by 0. However, please note if you put 0 over 5, that's a-okay. That just equals to 0. So 0 over 5 is okay, but anything divided by 0 is not okay. So any number divided by 0 is going to be undefined. So that's the first rule of fractions that we want to look at. So because of that, and I'll go over other rules of fractions as we go along and talk about how it pertains to rationals. But right now, let's take a look at number 1 and 2. So number 1 here has 6x minus 1 over 2x plus 8. And the question that they're asking is, find all excluded values in the expression. That is, find all values of x for which the expression is undefined. So basically, find x's, find what numbers, find x's that make this rational undefined. So what x's are excluded from here? And we call this basically finding the domain, right? Is finding out which values are excluded or included. So here's a fraction. We know here's a rational. We know from the rules of fractions that you can never have a 0 in the denominator. So I'm just focused on the denominator when I'm trying to find out what the domain is or when it's defined or undefined. So here, I know that the denominator can never equal to 0, right? You can't have it equal to 0 because if you do, you're going to get it undefined. So what values will make this equal to 0? Well, we solve it like we would a regular equation. We want to isolate our x. So I'm going to subtract 8 on both sides. So I end up getting 2x is equal to negative 8, right? Sorry, the sun isn't working very well with this board. And after that, I divide both sides by 2. I end up that x is equal to negative 4. So here, I realize that if I put a negative 4 in here, if you check this, if you put 2 times negative 4 plus 8, what are you going to get? Negative 8 plus 8. And that equals to 0. So therefore, if you plug negative 4 in here, that's going to make this rational expression undefined. So when they ask you find x's that make this rational equation undefined, x equals to negative 4 is the number that's going to be the problem spot. So that being said, let me give you guys a chance to go ahead and work on number 2. And number 2, if you look at your worksheet, says w minus 9 over w squared plus 2w minus 8. So again, same type of question. Find x's that make this rational undefined. So where do you look at? The numerator or the denominator? You look at the denominator, right? So if you look at the denominator, those are my eyeballs. You find out when does this equal to 0. So when does this equal to 0? So when does this equal to 0? Well, how do you solve an equation that's a quadratic? Well, you're gonna have to use factoring. So go ahead and try that, and I'll get back to you after this. Alrighty, so I am going to now put you guys into chat rooms to go ahead and work on that. Sorry, I'm still trying to figure this out. So,
Did you guys get W equals -4?
I'm confused.
I think we just have to make the rational undefined. So like, just make it over 0.
Okay.
Yeah, that's what I got.
I had a quick question. Are the links that you're sending me, since I'm in both of the canvases, so Math 130 and 140, are those the same exact link? They're both going to the same chat. You're muted, or I can't hear you.
I'm talking to
Oh, hello. Yeah, they're the same links, Garrett.
Okay, cool.
Yeah.
I wasn't sure if you were doing separate classes, but you've just combined everyone into one.
Yeah,
Okay.
because we're all on the same topics now.
Okay.
How about, does anyone want to answer? Anyone get an answer for number 2? Alexis?
Oh, snap! I'm on. Oh, I realized I wasn't on mute.
It's okay.
Sorry.
All
Hold
right.
on. So, I guess I can. This is what I have so far because I'm pretty sure I'm not done yet. But
Okay.
I did the since this the way this is made, I have to factor it. So I did the Xbox method, and ended up getting, what was it? 1W plus 4, 1W minus 2. So this is what I have so far.
Great. Great. So can you show that again, Alexis? Go ahead and speak up, and then we can see what you
Oh.
wrote.
Awesome. Okay. So in order to factor this out, because the way that this this is the form it's in, you have to factor it out. So since it's 1W square and -8, and we have to get the thing in the middle, we have to do the cross method. So I got 1W, 4, and -2. And that made 4W and -2W, and when you combine them, they get the middle one, so we know that's correct. And so create the, the correct equation with that, and I got 1W plus 4 and 1W minus 2, and that's my answer so far.
Great. Looks great. Anyone have any questions for Alexis so far? Good job. Can anyone continue on with what Alexis did? So she factored it using the Xbox method. What do we do next? Anyone want to chime in?
Don't you just set both equal to 0?
Can you show us your work?
Oh, me?
Oh,
Whoever's just spoke.
I haven't finished it. I was just chiming in.
Okay, great, Kayla. So Kayla says to set each factor equal to 0. So let's go ahead and try that. So what?
Are you able to use the quadratic formula to solve?
Not yet. We haven't learned it yet, but if you can, if you want, you can use it. But for these problems, it's easier to use factoring. Quadratic formula takes a little bit longer to do. So try it with factoring first.
Oh, you just plug it in after.
So when you set it equal to 0, what did you end up getting, Abraham? What were you saying?
What do you mean? Oh, just plug it in and you get 2 squared plus 2 parentheses 2 minus 8.
Can you show us your work?
Y'all see it right there?
Oh, when you talk, your screen will show up.
All right. Can you hear me? All right, for sure.
Yeah.
Y'all see the work there, or you know?
Yeah.
Okay. Good. Sorry, keep talking.
All right, so yeah, I just plugged it in. I got 2 squared plus 2, 2, which is 4, and 4 is 8 minus 8, and then it equals 0. So it's gonna be the W minus 9, it's gonna be over 0.
Very well. I'm going to continue the video that I was showing you guys earlier of how to finish that. Sorry, I'm still trying to figure out the Zoom thing, so it just takes me a little bit of a while to get used to it. How do I get rid of this? Okay, so I'm going to share my screen so you guys can see it right now and continue on with that video so that you can see how to continue solving that problem. What did I do with it? All right, so now that you've had a chance to take a look at it, what did you guys get as the answer? The answer is W is equal to -4 and 2. Okay, so check your work, and if you're not sure how you got that, let me explain. So what we're gonna do is, because it's a quadratic, the highest exponent is 2, I see it equals to 0, so since there's 3 terms, there's no GCF, so I'm gonna Xbox it. So I'm gonna zoom through Xboxing right now. If any of you guys are still struggling with Xbox, please make sure you go back to my previous videos on Xbox. Here, what 2 numbers give me 8? Well, 4 and 2. One of them is gonna be negative, I'm not sure which one yet. I exit, I get 2W and 4W. Can I add or subtract this to get me 2W? I sure can. I could do -2W plus 4W will give me 2W. My winner chicken dinner numbers, so I need a negative right there. And 4 times -2 is indeed -8. So when I box that, I get W minus 4 times, W plus 4 times W minus 2 is equal to 0. Sorry about the glare, guys. Okay, and then I'm going to have to use a zero product property where I set each factor equal to 0 and I solve for W. So I subtract 4 here, so I get W is equal to -4, and then I add 2 on both sides here, and I end up getting that W is equal to 2. So that's why -4 and 2 are the answers. And if you want to check your work, if you plug -4 in here, you're going to get a 0. If you plug 2 in here, you're going to get a 0. And we know that a fraction with a 0 in the denominator is undefined. All right, in the next question here, we're asked to evaluate rational functions. Well, this is kind of a little bit easier because it's nothing new from what you've done before. When it says to evaluate a function, basically it means just to plug the number, the input inside the function and then spit something out, right? So here, find h of 5. Remember, this does not mean multiplication, not multiplication. What it means is that this is a function where the input is 5. So if you remember what a function is, in our previous section, a function is a machine where if you put a number in, it spits something out, right? And whatever you put in, so here in this case, we put in the number 5. So we put in 5 into the flip machine, and the machine is called H, and it takes in that number 5. So it's written as H parentheses 5, meaning it's gonna take in the 5 and eat it up and do something with it. Well, what is it gonna do to it? It's gonna do this to it. It's going to do the 5x over 3x minus 9, and then it's gonna spit out an answer. So here, when I plug in 5 in here, so h of 5 then, when I plug in 5, I'm gonna do 5 times 5 over 3 times 5 minus 9. Okay. So go ahead and try that once you plug that all in. Okay, so I realized I just made a mistake. Sorry, I'm human. So it's actually 3x minus 19 based on your worksheet. So based on the worksheet, if you plug this in, go ahead and plug in the 5 in here and see what you get. How do I get back on here? Alrighty. So let me just call on someone, give you guys a chance to do that. Plug it in, plug it in. There's some background music there, I like that. Dante, I see you on there. Were you able to get an answer? Do you need more time?
No, I think I got it. So
Would you-
basically, I got 25 as your top, and then for your, I believe, denominator will be 15 minus 19 after you plug it in,
Mhm.
and then I just subtracted that, and I end up getting 25 over -4.
Great. So 25 over -4 is the correct answer. Great
Yeah.
job. Are you, just wondering, Dante and others, are you guys able to show your work when you guys are speaking? Can you do it on your laptop or camera by any chance?
I have to get a camera actually. My
Oh.
my other camera just broke, so I should be getting that one soon though.
Are you using your phone?
No. I'm actually on my computer.
Oh, okay. Just wondering. Great. All right. Any questions with what Dante did? The answer is -25 over 4.
You just leave it like that?
Yep. You can leave it
Alright.
like that. You can put the negative on the top or the bottom. Both is A-okay.
What if you solve it? Will it be incorrect?
I'm sorry, say again?
What if you divide it? Do you get the answer incorrect if you divide the term you get?
Not really, because you would get like a decimal as a
I got -6.25. That's why.
Oh, they know.
Right. Yeah. So if you answer as a fraction or as a decimal, even though it's technically correct, you actually want to leave it as a fraction. Since the problem started as a fraction, you want to end up as a fraction as well. Good question. Any other questions? No such thing as a bad question. All right. So let me go ahead and continue on with the next problem. Oops. All right, so the answer should be 25 over -4, and this is the work for it. Keep in mind, you can put the negative on the top or on the bottom or on the side. It doesn't matter where the negative goes. All right, so now let's get into more of the heart of rationals. So right now we're going to talk about how do you simplify rationals, and this is covering topics number 5 to 13 on your worksheet. So when we talk about simplifying rationals, let's first talk about how do you simplify fractions. So just a review of how we normally simplify fractions. If I had, for example, the number, say 4 over 16, right? And I say to simplify it, meaning to write it in its lowest terms. So we basically look at the top and the bottom, and we say, what do the top and the bottom have in common that it's divisible by? In other words, what factors does it have in common? So the number 4 here, the number 4, so what we normally do, is that we divide the top and the bottom, but what they both have in common, what factor they both have in common, they both have a 4 in common. So because they both have a 4 in common, we write this in simplest terms, which is 1/4, right? So let's make this a little bit harder. So what if I had something that said, so let's just make it look a little bit more complicated. What if I had 8 times 2 divided by 16 times 9, right? So these are what we call factors, because factors are things that are being multiplied with each other. 8 is a factor, 2 is a factor, 16 is a factor, and 9 is a factor. What we could do is we could just multiply it all out and then simplify it, but actually the better thing to do is to simplify it first. So I ask myself, well, what do the top and the bottom have in common? Well, I look at the factor 8 and the factor 16 here. 8 and 16 both have an 8 in common. So I'm going to divide the top by 8, right? If I divide the top by 8, I get a 1. If I divide the bottom by 8, I get a 2, right? And then what do you know? There's a 2 and a 2 here as well. So these are factors. And if I divide the top and the bottom by 2, that's their common factor, I'm going to get 1 and a 1. So as a result, the answer is going to be 1 times 1 on top is 1, divided by 1 times 9 on the bottom is 9. Okay. So when we simplify fractions, sorry, my knees hurt right now. When we simplify fractions, one of the things that we want to do is to write it as factors. If you write it out as factors, things are being multiplied with each other, then you could cancel out or divide out common factors. So let me just give you one more example of this, just to really hone in the point. If I had a bunch of numbers, say 3 times 4 times 8 times 7, just making it up, divided by a bunch of other factors, say 4 times 9 times 8, right? So just a bunch of factors that are being multiplied with each other. What you can do then, instead of multiplying it all out and then just having to simplify really big numbers, instead of doing that, what you're going to do is you're going to divide out the common factors, or what you would say, cancel out common factors, right? So here's a 4 and a 4. They both have a 4 in common, so I divide it out, so I get a 1 and a 1 there. What else? The 8 and the 8 also cancels out, so you get a 1 and a 1. Anything else? Okay, there's a 3 and a 9. The 3 and the 9 have a 3 in common, so divide the top by 3, you get 1. Divide the 9 by 3, you get 3. So as a result, on top, if you multiply the top, you get 7 over 3, right? That's a lot more simpler to do than multiplying it all out and having to deal with really big numbers. So now let's take a look at how we apply this to simplifying rationals. All right, so here we have this ugly looking thing, but guess what? You have the tools to simplify it, even though it looks complicated. It's the same rules as we did with fractions. So here's a numerator and here's a denominator. So these are already factors. So it helps me to circle what the factors are, just for you to really see it. Here's a factor. So factors are things that are being multiplied with each other. Factors, factor, 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 factor. Right? Those are all factors. So I say, what factors in the numerator and denominator are common that I can cancel out? In other words, so I look at the 35 to 20 first. So I'm going to look at the 35 to 20 here. Say, okay, just look at numbers. How can I simplify this? What do they have in common? They have a 5 in common, right? So if I divide the top by 5 and the bottom by 5, I end up getting 7 over 4. Great. So this becomes a 7 on top, and the bottom becomes a 4. Now I look at this part here. I have 3u plus 7 to the third. I say, what factors does it have in common with the denominator? I see this here that looks something similar to that, 3u plus 7 to the fourth, right? So the hard way of doing this is you write 3u plus 7 3 times, right? You write it down 3 times. And 3u plus 7 to the fourth, meaning you write it out, you multiply it by itself 4 times. So this is very tedious, but I just want to show you, again, something called the quotient rule. So here you cancel common factors. These are common factors. If you divide it by 3u plus 7, they cancel out to become 1. These cancel out to become 1. These cancel out to become 1, right? Common factors. So you're left with 1 over 3u plus 7, just one of them on the bottom, right? So this is very tedious to do, to write it all out. So I just want to remind you guys of the quotient rule. Thank God for the quotient rule. So the quotient rule says that if you have a to the m over a to the n, remember what do? You do the top exponent minus the bottom exponent. So here the bases are the same. So if I do 3 minus 4, so the top minus the bottom, I end up getting 3u plus 7, top minus bottom, 3 minus 4 is negative 1. And since it's a negative exponent, you bring this to the bottom of the fraction, which therefore becomes 1 over 3u plus 7. So this here becomes a 1, and this here just becomes a 3u plus 7 to the first power, right? And then last but not least, let's look at the u minus 5. Sorry, this is getting kind of messy. So when I look at the u minus 5 here, I see u minus 5 to the fifth over u minus 5, and it's just to the first power, right? So again, I'm not going to write it out like this, how I did before. I'm going to use the quotient rule to simplify this. 5 minus 1 will give me u minus 5 to the fourth power. So this here cancels out, so I end up getting u minus 5 to the fourth. super messy, right? So what I'm gonna do is I'm gonna erase this just so you can look nice and neat. So I end up getting on top 7 times 1 times u minus 5 to the 4th. So I end up getting 7 times 1 is just 1 times u minus 5 to the 4th, right? And the denominator, I have, I think I accidentally erased this, but there's a 4 here. In the bottom, I have 4, and this one, right? I had a 3u plus 7 to the first power, and I accidentally erased it, sorry. So on the bottom, I have 4 times 3u plus 7, and you don't have to write to the first power. So as you can see, something really ugly and complicated turned out really simple and pretty. And that's one of the goals of math, is you want to make complicated things simplified. Alrighty. Let's see.
Professor, I have a question.
Yes, go ahead.
Sorry. I understood most of it, but I think where I got lost was the 3u plus 7 over the u minus 5. How did you get the u minus 5 equal u minus 5 to the 4th power? How did you do that?
I'm sorry, can you say that again? The 3u? Which
It
one?
was 3u plus 7.
Okay.
I think it's 3rd power over the u minus 5. And then the answer you got was u minus 5 to the 4th power.
Okay.
If I got it correct.
So sorry, I had erased my work. I should have left it up here. So when we started off, can you see that? Okay.
Yeah.
So we had 3u plus 7 to the 3rd power times u minus 5 to the 5th. I'm just going to rewrite this problem real quick. U minus 5 times 3u plus 7 to the 4th, and we had a 35 over 20. All right. So your question, so the first thing I'm looking, because these are all factors, right? Factors, 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 factors. And when we're looking at factors, we want to see which are the ones that are similar factors so we could cancel and simplify it. So what I did is I took the 3u plus 7 to the 3rd and 3u plus 7 to the 4th to simplify that.
I see now. I see where I got it mixed up.
Is that okay? Yeah. And then
Yeah,
this
okay.
one combined with that one. Okay.
Oh, yeah.
Okay.
Thank you.
Great question, Jessica. Thanks for asking. Any other questions so far? No such thing as a bad question. And remember, just unmute yourself if you guys have a question.
So
All right.
sorry.
Go ahead.
Yeah, when you divide the powers, so you're not subtracting the powers whatsoever, like the what was it? Because with a u minus 5, I thought you were supposed to subtract it by. Oh, never mind.
You got it?
Yeah, never mind.
Sometimes just asking the question, we help answer our own question. Any other questions? And just letting you know, all these videos that I'm posting up, I will put them online for you guys as well, and I'll put it in chunks of topics, so you don't have to look at the whole thing. Okay, if there's no other questions, I'm gonna have you guys go ahead and try this with, actually, rewind. Before I have you guys try it with groups, I'm gonna do another one with you guys that's just a little bit harder. So let's try number 11. So number 11 here. So this is a little bit harder because it's not written in the form as factors, right? So factors are things that are being multiplied with each other. However, this is not written in a way that it's factored. So because it's not written that way, guess what we're gonna have to do? Factor. So the first step here is we need to factor. So we need to factor the numerator and the denominator. Because in order to cancel things out and simplify, it has to be in factored form. So to factor, good thing we know how to do this from the previous chapter. So to factor this, I look at the top. There's 2 terms, but before I try to do anything fancy, the first thing I'm gonna do is find a GCF, right? So 32 and 2, what is a GCF? And I think you guys are unmuted, so feel free to speak up if you guys would like.
2.
I'm sorry?
2.
2, right? The GCF is 2. So I'm gonna pull out the GCF, and inside it's gonna be two spots. 2 times 1 will give me 32. 16, right? And then 2 times what will give me negative 2w squared, a negative w squared. And I always double check. So what I do is I always just multiply through here to make sure that I get the original right there. The denominator, I have w squared minus 2w minus 8. So first of all, I ask myself, is there a GCF? And the answer is no. So next I'm going to say, well, there's 3 terms, so I'm going to have to factor it. So I'm going to have to factor it by using Xbox method because it's 3 terms. So if I factor that, I have w times w give me w squared. 2 numbers that will give me 8 is 4 and 2. One of them is going to be negative. Not sure which one yet. So I'm going to cross multiply to do the x. Oops. And when I do the x, I get 2w. W times 2 is 2w. W times 4 is 4w. Can I add or subtract this to give me a negative 2w? Yes, I can. If I put a negative 4w there, I end up getting negative 2w. So that means I need a negative here, and the negative 4 times 2 does give me negative 8. So these are my winner chicken dinner numbers. So when I factor this, it becomes w minus 4 times w plus 2. So when I look at this, I'm like, okay, I'm done factoring. But guess what? You're actually not done factoring because remember the factor man, when we looked at that sheet, you want to factor everything to death. If I look at 16 minus w squared, these are 2 terms. Can I factor this anymore?
Yes.
Yes, you can. And you can factor this, and since there's 2 terms, it's either going to be a dots, a difference of 2 squares, a doptica, difference of 2 cubes, or a soxtica, a sum of 2 cubes. What do you guys think this is going to be?
Difference of 2 squares.
Right. 16, it's going to be a dots, right? So here, 16 minus w squared is going to become, anyone know what that's going to be? Difference of 2
4 minus 2.
4 minus w.
4 minus w times,
2.
not 2,
No,
but
not 2. 2.
again, 4 minus w times,
4 plus w.
right. Good job. 4 minus w times 4 plus w. So remember the difference to 2 squares is a squared minus b squared is equal to a minus b times a plus b, right? So your a is 4, because 4 squared gives you 16. Your b is w, because w squared will give you w squared, right? So 4 minus, so it'll be 4 minus w times 4 plus w using dots. So again, if any of you guys are fuzzy-wuzzy on how to do the dots, please make sure to go back to the previous chapter and watch my video on difference of 2 squares. But right now, I have this. So let's just make it nice and neat. A lot of math is about organizing your work. So 2 times 4 minus w times 4 plus w all over w minus 4 times w plus 2. So these are all factors now. So I have factor, 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 factor. Do any of these factors look the same? Is there a no?
The 4 minus w and the w minus 4 are the closest thing.
It
Great.
wouldn't be, would it?
So Alexa said the 4 minus w and w minus 4 looks the same. So let's take a look at that. So I'm gonna pull that out here. So let me erase this real quick. So I'm gonna pull this out, the one that Alexa said. So 4 minus w over w minus 4, are these the same?
No,
Why not, Tim?
because it's a negative w, and on the bottom is not negative w.
Okay, great. So the 4 here is positive, the 4 here is negative, and like Anthony said, the w here is negative, but the w here is positive. So they're not exactly the same, but they're so close. And actually, if you pulled out a negative, so what I'm gonna do is I'm gonna show you something. They're exactly the opposite. This is a 4, negative 4. Negative w, positive w. So what you can do, if you pulled out a negative, if you distributed out a negative or factored out a negative from the top, if you took out a negative on the top, this 4 will become a negative 4, and this negative W will become a positive W. And here, I'm going to just switch the order here so you can see this is negative 4 plus W. So what you're going to see here is that negative 4 plus W, negative 4 plus W, they're exactly the same here. I put a 1 and 1. This actually equals to negative 1. So I know that's a little bit confusing. So when the top and the bottom are exactly the opposites of each other, meaning here's a positive 4, here's a negative 4, here's a negative W and a positive W, the answer becomes a negative 1, right? Because let me just show you something. If I had A divided by A, right? If the top and the bottom are exactly the same, you just get a 1, right? But if I had an A over negative A, if they were exactly the same, but they're just different by just a negative, then the answer would be a negative 1, right? That's the same story with this. 4 minus W and W minus 4 are exactly the same, except they're exact negatives of each other. Just by pulling out the negative here, I put out a negative to show that the top and the bottom are exactly the same except the negative, and that becomes a negative 1. So it's a little bit tricky. That's why I did this problem. So 4 minus W and W minus 4 now becomes a negative 1, and a negative 1 is just a negative, right? So you can put the negative 1 on top or negative 1 on bottom, it doesn't matter. So when I now simplify this, I get 2 times the negative 1, that gives me negative 2 times 4 plus W. The bottom, well, the W minus 4 and the 4 minus W canceled out, right? So that just became a 1. And then here I have a W plus 2. So again, it's not easy. This is pretty challenging. So this is our final answer. And notice there's a 2 here and a negative 2 here. A lot of students think that they can cancel out the 2, but you cannot cancel out these 2 because W plus 2 is a factor. The 2 is attached to the W, so you can't just cancel it out just because you see it on top as well. W plus 2 is a factor. It's stuck together. You can't, basically, like, you can't chop off an arm from a head, from a body, right? So W plus 2 is a whole body. You can't chop it. So you can't take it out in pieces. They're together, right? I know it's a little bit challenging, so we're going to do a few more examples. Do you guys have any questions on this? I know, so take it all in. Let me give you guys a chance to, do you guys want me to do another example, or do you guys want to do a you try, where you guys do it on your own?
Can you do another example, please?
Sure, sure. Let's look at number 8. So number 8 is going to be something similar to what we just did here with the W, 4 minus W and W minus 4. It's really to hone in the point that if they're opposites, you can simplify it to make it a negative 1. Okay, so looking at number 8 here, I have 4 plus 3v over 3v plus 4. That's the first part. And the second part is this. And where's my blue marker? I lost it. All right, so the first part. First of all, can I factor this? 4 plus 3v. Can I factor 4 plus 3v?
No.
No, right? Can I factor 3v plus 4?
No.
No. So since it can't be factored anymore, this is a factor, this is a factor. So that's all, this whole thing's a factor because it just is what it is. You can't do anything more with it, and this is a factor. And then I ask myself, well, are these the same? If they're the same, then I can simplify and cancel it out. Are these two the same?
Yes.
Yes, right? Positive 4, 3v, 3v. It's like saying a cat plus a dog, the same thing as a dog plus a cat, right? They just switch the order, but they're the same. So again, if they're the same, you get divided by itself, so it just becomes a 1, right? This one's a little bit trickier. First of all, can I factor it?
No.
Nope. It's already factored as is, right? You can't make, there's no GCF. So therefore, this is a factor and this is a factor. You can't break it up anymore. Are they the same?
Yes, kind of.
Kind of, right? So Felicita, can you explain why do you say it's kind of?
Because like the last problem where you took out the negative.
So let's say I'm going to take out a negative here. If I take out a negative, what does the inside become?
-7 plus 2v.
Great. Now, is the top and the bottom the same?
Yes.
Yeah. Great, good job. So the top and the bottom, this is a positive 2v, positive 2v, -7, -7. These are the same, so we can cancel them and it becomes a 1. So I have a 1 divided by -1, which would just give me
-1.
-1. Any questions on that? Okay, and again, if it's not super duper clear, that's okay. Just make sure the first time you see it, it might seem a little bit funky. But you have chances to work on this on your homework as well. Where's my eraser? Sorry, this is just like class. I'm always losing stuff. All right, let's do, let me do another one. Or actually, let me have you guys do it. Let's have you guys go ahead and try. Let's go ahead and try. Try number 10. I'm going to break you guys up into your groups. Or why don't you guys go ahead and just try it on your own first? Try it on your own first. And then I will break you guys off into groups and give you guys a couple minutes to discuss. I'm sorry, Anthony, can you say it again?
I got 2 parentheses y plus 5 on the top and then y minus 1 on the bottom.
Okay, so Anthony, you said you got 2 on the top, right?
Yeah.
So walk with me. How did you get a 2 on top? What did you do?
So I factored out 4y squared minus 100. So I factored out 2y minus 10, parentheses 2y plus 10.
Okay, so you did 2y minus 10 and 2y plus 10?
Yes.
Okay, so let me just write this down here. 2y minus 10 and 2y plus 10, okay. And then what?
And then on the bottom is y minus 4 and y minus 5 and y minus 4.
Got it, that works, okay.
And then on the top, I factored it out even more. So it'd be, I factored out the 2 and it would be y minus 5, y plus 5.
Got it, I see how you got that. All right, so I'm really grateful that you brought that up, Anthony. The mistake here, well, the first mistake is that you did the difference of 2 squares before you took out the GCF, right? So remember when we do GCF, or whenever we factor, the first thing you want to do is pull out the GCF before you do anything at all. So the 4y squared minus 100, it actually has a 4 in common. So when you pull out the 4, you get 4 times y squared minus 25, and then you do dots. So because you did dots first, you end up getting 2y minus 10 times 2y plus 10, which is okay. That's not wrong. But then be careful of the next step, because the error is that you pulled out the 2 out of here, right?
Yeah.
You pulled out the 2 here, but notice you also need to pull out a 2 out of this one as well. So when you pull out a 2 out of this one as well, you actually need to pull a 2 here. 2 times 2 is actually 4. So 4 times y minus 5, y plus 5.
Yeah, I was gonna do that at first, but then I second guessed myself. I thought it was gonna be.
Well, this is a great time to figure out how to do things. But right, so if you happen to not pull out the GCF and you end up doing dots first, make sure you pull out the 2 out of both of them. So you pull out a 2 out of both of them, 2 times 2 is 4.
Okay.
Okay. Or better yet, to be safe, pull out the GCF first and then do dots. And then that way there will be less room for error.
Okay.
Good question. Any other questions? No other questions? Alrighty. Let's do, I'm just gonna do one more with you guys just to really make sure you guys know how to do simplifying fractions. There's a lot of questions on the worksheet. Yes, is there any specific one that you guys want me to do from up to number 13?
Can you do 13?
13, sure. Okay, let's try 13 here. Again, my markers are rolling all over the place. Okay, 13 here. I like the music background. All right, so right now I'm just gonna mute you guys all for a second. All right, so here in this problem, we have this rational. So the first thing I'm gonna do is I'm going to factor it to see if there's anything that I can cancel out. So I look at the top and I see 2 terms, but before I think of dots, doctica or soctica, I'm gonna ask myself, can I factor anything out? Is there a GCF? So 5 and 15 both have a GCF of 5. They both have a GCF of 5. X and V, y squared, and y to the 4th. Is there another GCF? Not X, not V, but y squared and y to the 4th, they both have a GCF of y to the 2nd. Right? So it's going to be the smaller of the 2, right? So it's going to be the smaller of the 2, which is y squared. Right? So now, taking out the GCF, inside I have 2 terms, so I have 2 blanks. So 5y squared times what will give me the first term? So it's missing a x. So 5x y squared. So I check myself. When I distribute it, I end up getting the first one. 5y squared times what will give me the second term? 5 times 3 will give me 15. It doesn't have a v, so I need to put a v here. This is y to the 4th. So if I have y squared to get to y to the 4th, I need a y squared. Right? So again, I always double check my work because I make mistakes. So just double check my work. I distribute it out just to make sure that I get this answer. Okay, now the bottom part, I can't factor out one term. It's just 15y cubed, right? You can't do anything with that. So that stays as it is. Alrighty, so now that it's in factored form, so I'm going to circle my factors. Sorry, my marker rolled under the ground. So I'm going to circle my factors. Factor, 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 factor. So factors are things that are being multiplied with each other. So this top here, what is being multiplied with each other? This, and this whole shebang. What is being multiplied with each other? The 15 and the y cubed. So it's helpful for me to circle the factors so that I know what I can or I can't cancel out. So here, I can't cancel out pieces of factor. This whole thing comes together. It's one body, right? Don't chop off people's arms and legs when you're canceling things out, right? This is one body. You cannot separate those things. Okay, so now when I look at this, I say, what factors does the numerator and the denominator have in common? So I look at the 5 and the 15. Those are numbers. 5 and 15, I can cancel that out. So 5 and 15 divided by 5 on top, divided by 5 on bottom, I get 1 over 3. So this becomes a 1, and this becomes a 3, right? So then I also look at this again, and I say, what other factors do they have in common? I see a y squared and a y cubed. So y squared over y cubed I'm going to use the quotient rule where you subtract the top minus the bottom. So y2 minus 3, I end up getting y to the negative 1. I don't want a negative exponent, so I have 1 over y to the first power. So therefore, this becomes a 1 on the top. The bottom just becomes a y to the first power. This here, x minus 3vy squared, that just stays, it's a whole body. There's nothing that looks like that on the bottom. So I'm going to clean this up a little bit. So my final answer then is going to be, well, 1 times 1 is just 1 times x minus 3vy squared. That's the top. The bottom is 3 times y. So again, this is the answer, but be really careful that you do not feel tempted to cancel out the 3's here or the y's here. The reason is because this whole thing is a factor, that's why I circled it. You can't cancel out pieces of a factor. It's like a whole body. You don't want to cancel, you don't want to chop off an arm and a leg and a head and a leg and an arm and whatnot. So you keep it together. You can only cancel out things that are exactly the same as on bottom.
Is that a negative 3y in the bottom or a 3y?
Oh, this is a positive 3y. Oh yeah, sorry, this is a.
Oh, okay.
Yeah. Good question. All right, any other questions on this? All right, so again, what we're doing here is not enough for you to get really great at simplifying, but you'll have a lot of chances to do this on your homework. And again, if you guys have any more questions, just let me know. But right now it's 11:37, and I wanted to give you guys a 10-minute break. So if you guys need to go to the restroom or do whatever you need to do, 11:38 right now. Let's come back at 11:48, okay? See you guys soon. All right, so at this time, we're gonna do a few spotlights. I have Jessica who volunteered. Let's see, Lakonda, Naomi, Alexis, or Anthony. If any of you guys want to share today as well, let me know. Okay, you could chat with me on the side here and let me know. I'll pull it up. But let me go ahead and pull up Jessica's real quick. Give me 1 second. Alrighty, Jessica, you're on. 3 minutes, up to 3 minutes.
All right, you guys. So my name's Jessica. I'm a studio arts major. So a couple pictures I have up here. If you look to the top left, that's me and my partner. He's a very big support. Like, he supports me a lot, so he's super important in my life. And then below is my family. We actually went to Big Bear in February. So I'm happy we got that in before the coronavirus came up. Well, it was still going, but yeah. They're super important to me as well. And they're a big support system for me. And then above is my 2 jobs. I was working at Panera, and I was working at Long Beach City College, but with everything at school, I'm not working there right now. But I really love my job at Long Beach City. I work for the metals and jewelry department, and I'm an embedded tutor. So that's like I love that job. And then next to it is a picture of the pyramid at Cal State Long Beach, because that's probably where I'm gonna go. I haven't really researched too many other schools besides that one, but they have a really good metals and jewelry department there, so I have to go check that out. And then right below is some pieces that I did in fall semester of metal castings of like coral and stuff like that. So that's some of my work at the bottom, and that's pretty much it for right now.
Very cool. Any questions, Jessica? So is Panera Bread closed right now?
Yeah, pretty much. Like the store that I was at, because I'm supposed to be transferring to another store, and they just told me not to come in anymore, and that I'm pretty much laid off until further notice.
Oh man.
Yeah, I think they're gonna be closing all the cafes down eventually.
Wow.
You said you made those rings in the bottom corner?
Yeah, those, yeah.
That's awesome.
Yeah, I love those. Casting is really fun. It's a really cool process. Those were all made out of wax first, and then we put them in a kiln, which melts all the wax out, and then we pour metal into it. So those are silver, sterling silver, and bronze. Yeah.
Very cool. And you said you're an embedded tutor for that class?
I'm an embedded tutor for the beginning jewelry class. Yeah.
Oh, cool. Are you at Long Beach City College?
Yeah. At Long Beach City College. Yeah.
Cool. So you're still working with them right now, right? You're still
It's kind of hard for that class because it's more hands-on and we don't have all the equipment. So like we're trying to figure out like alternatives of what the students could do. But we're still in the process of all that. So I'm not even sure where I'm gonna fall in between, all of this stuff. So but I would hopefully be able to still work.
Right. Cool. Any other questions for Jessica? And I'm glad you got to go to Big Bear right before all this happened.
Me too.
Yeah, I just went to Mountain High right before all this happened too. So glad I got that in.
I know I was supposed to go to Seattle, but we just canceled our tickets because I was like, it's probably terrible over there too. So
Right.
Yeah.
Better to stay safe.
Exactly. Yeah.
Well, thank you, Jessica, for sharing. That's really neat what you're doing. Let's see. What is this? Oops. Okay, still trying to figure this out, sorry. Okay, I can't see my Zoom in for the moment right now. Oh, here it is. Stop share, that's why. Okay, how about share screen? How about Naomi? Naomi.
Can I go next? If no one's up, oh, never mind.
Oh, who's that? Is that Anthony?
Abraham.
Abraham. Okay, do you have yours up already or?
Yeah, I sent two.
Oh, I got it. Here, I'm gonna put it up real quick. And we got some background music as well. Okay, let me just slideshow. All right, Abraham, you're on.
All right, so besides the picture of my wallet, I keep it right there to just, just keep me up. I guess my nephew, my little brother, and me. Right there on the bottom right, it's me. The two on the left is my nephew. On top of me is my little brother. And under that, it says Mexican American, and I'm like both. So I take I like my culture,
Good.
And then right there in the middle, some boxing gloves. I'm a boxer once in a while. And then the next to it is some shoes. I'm a shoe guy, kinda. I got those exact same pairs, but they're kind of messed up right now. I've been through some stuff. And right there's a quote that says, "The struggle you're in today is developing the strength you need." So saying anything that you went to today is gonna help you get stronger for tomorrow.
That's a great quote.
Any questions?
Any questions for Abraham?
How long have you been boxing?
Well, it's on and off. I'm not really I don't try like that. I just go just to work out and box. Yeah.
And what are you studying? What are you struggling through today that you want to be strengthened for tomorrow?
Let me see. My phone, it broke. Look at it.
Sorry to hear that.
Got this one though. This one's messed up too though.
What are you studying, Abraham?
I'm going for business.
Oh, okay.
Yeah, that's pretty much it.
And what number are you in terms of your brothers?
I'm the second youngest. There's 6 of us in total.
Wow, all boys?
Nah, one girl.
Oh, okay. Are you guys all pretty close?
Yeah, one of them's got deported. He's in Mexico right now.
Oh, I see.
One of my brothers. Yeah.
Sorry to hear that.
It's cool.
Great. Thank you for sharing, Abraham. Are there any other questions for Abraham?
No,
All
I
righty.
don't think so.
Thank you. Good job. How about I have also for let's see, Lakonda, you said, do I have to have my video on or can I? You can just talk, Lakonda. I actually have yours up here. So, Lakonda, can you hear me?
Yeah, I can hear you.
Okay, so let me go ahead and put yours on. Let's see, this is yours, right?
Yeah.
One whole page. Alrighty, you're on.
Okay, so I have 2 brothers and 1 sister. So I'm the baby. I'm married, been married for 3 years. The last place that I traveled to was to NASA, and we went on a Disney cruise with my family. It was about 10 of us. My major is nursing, and I have 2 kids, a boy and a girl. I'm not so big with math, but I try and do the best I can. My favorite subject, I want to say, would be English. What else? I love watching basketball. I love football. And one thing you don't know about me is I'm not a big talker. I get what is it? Not starstruck, but I get nervous when I speak in front of people. So me not having a camera on, it lets me speak, you know. So yeah. And that's it.
Oh, any questions for Lakonda? How old are your kids?
One, he's turning 3 in April, and then the other one's 10.
Okay, so they're both at home with you right now?
Yes.
All right. Well, congrats on your beautiful family.
Thank you.
I see this picture here on the left corner. Is that for nursing or?
Yeah.
Okay.
Nursing.
And you did a great job speaking, even though you don't like to speak.
Thank you.
I know it could be a little bit nerve-wracking, like talking over the computer, especially.
Yeah, it can. But I did it.
Any other questions for Lakonda?
Is that middle picture like you as a kid? And
Yeah.
I like your brother's shirts. Those are pretty cool.
Yeah. The second oldest, he's matching my mom. And then the youngest brother was matching my dad. And then I was matching my dad. And then my sister was matching my mom.
Oh, I like the color coordination. Cute. Any other questions? All righty. Great. Thank you for sharing. It's kind of nice just to make it a little bit more personable, to see, you know, I know we're distance, but to have some type of personal contact and see who's in our class. So thank you for sharing, you guys. And Anthony, I see that you said you'll share on Wednesday. That's fine. All righty. And then towards it, is group 3 here by any chance?
Yes. Me and Stephanie are, I believe. But we want to have the opportunity to do the group presentation on Wednesday.
Okay, that's fine.
Thank
So,
you.
so who is that? Alexis and Stephanie for group 3?
No, we're group 4, I believe.
Oh, okay. Group 4?
Yeah.
Okay.
Yeah, group 3 is me and Paloma.
Oh, it's Stephanie and Paloma. Sorry.
Yes.
Yeah, I was saying I can do spotlight if you needed, if you wanted me to do spotlight today, not a group press. I think that was a misunderstanding in the chat.
Oh, got it, got it. Sounds good. Actually, Alexis, I'll have you do the student spotlight on the Wednesday, if you don't mind.
Yeah, sounds good.
Okay, cool. So group 3, Stephanie and Paloma, you guys will be presenting on Wednesday.
Yes, please.
And how about the other class, group 3?
Well,
We're also presenting on Wednesday.
Okay. So who's that? Angelica and is that Angelica?
Oh, no, I'm from group 3 as well, Diana.
Oh,
And
Diana.
yeah, we'll do it on Wednesday.
Okay, so on Wednesday we'll have group 3, Stephanie, Paloma, Angelica, Diana, and whoever else. Oops, my phone. And also we'll do student spotlight, and I'll have Alexis do it on Wednesday as well. All right, and I'll just be alternating between either the 10 o'clock class or the 1 p.m. class. So I'll be alternating both of the times so that I can catch both populations. All right, so without further ado, let's go ahead and continue on with this last portion of this section. So as you can see, I didn't do all of the questions on the worksheet on simplification, but I tried to do some of the harder ones so that you guys can get started and know how to do it. But of course, at any time, if you guys have any questions on any of those questions, feel free to email me, canvas me, or Facebook message, either me or Garrett, if you guys have any questions, and we can help you along with that. So you're not alone trying to figure this stuff out. The last section here is on multiplying and dividing rationals. So multiplying and dividing. So we're starting off with multiplying, dividing rationals instead of adding or subtracting, because adding and subtracting is actually the harder thing. Because as you know, when you add or subtract fractions, you have to have a common denominator. So therefore, you have to find the least common denominator. So that is a lot harder than multiplying or dividing. So we're going to start off with the easier one. When Wednesday hits, we're going to do the adding and subtracting, which is a lot harder. So I just want to warn you of that. So let's talk about this. So I'm going to review how to do this with fractions. So with fractions, we realize, so say if I had 3/4 times 2 over 9. So we deal with this with fraction. We know that we do not need a lowest common denominator. So LCD is not needed when you're dealing with multiplication of fractions. So all you do, one of the things you can do is you just multiply across, right? You multiply the numerators together, you get 6. You multiply the denominators, you get 36. And then you simplify it. So then you top and bottom divided by 6, you get 1 over 6, right? So that's how we do with fractions. However, I'm going to write down the same problem right now. So when we deal with rationals, instead of multiplying across and simplifying, you're actually going to have to simplify first. So here, I'm going to practice simplifying first before we, am I recording this? Yes, I am. I'm going to simplify this first before we multiply. So what I do is, so you can write this all as one fraction if you want as well. If you want to write it as one fraction, that's 40, that's fine as well. Can you see that? There you go. So you can write it all as one fraction. You multiply top and multiply the bottom. And just like what we did earlier, we can see if these are our factors, right? Factor, 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 factor. And then I ask myself, is there anything common on top and on bottom that I can cancel out? So the 2 and the 4 both have a 2 in common. So 2 divided by 2 is 1, 4 divided by 2 is 2. The 3 and the 9 have a 3 in common. So 3 divided by 3 is 1, 9 divided by 3 is 3. So as a result, 1 times 1 is 1 on top, 2 times 3 is 6 on bottom. Same exact answer as that. So as you can see here with fractions, you do not need a lowest common denominator, and all you do is you simplify it by canceling out common factors on top and bottom, and then you multiply across. So that being said, let's go ahead and do that with rationals. And sorry if I'm erasing it before you're able to take the notes, so feel free to, when I post this up later, you can take the notes that you might need. So I'm gonna try doing number, like my pause, Let's go ahead and try doing number 15. So 15 here. Now we're multiplying rationals. So now it doesn't look as clean and simple as what we did earlier, but it's going to be the same idea. So that's the lovely thing about math. The rules are always the same. So right now, when I look at this, remember what we did earlier, where we can only cancel out common factors. So therefore, the key thing is you need to factor it before you simplify. So before you do anything, you must factor everything so that we can simplify. So when we simplify, that's what we say cancel out, right? When we cancel out common factors, right? So we have to factor everything first. So every single part here, x minus 3, can I factor that? No, right? It's already factored. X squared plus 3x plus 2, can I factor that? I sure can. So let's go ahead and factor that. So again, if I didn't emphasize enough already how important factoring is, now you can see why it's always coming up. So here I factored this, x times x will give me x squared using Xbox method. Two things that are multiplied to give me 2 is 2 times 1 will give me 2. I exit. When I exit, I get x here and 2x here. It adds up to give me 3x. So winner, winner, chicken dinner. Those are my answers. So therefore, this is what happens when I Xbox it. So this here now becomes x plus 2 times x plus 1. So I'm going to erase this. And I'm going to put x plus 2 times x plus 1. So x plus 2 times x plus 1. Right. Can I factor this guy? I sure can. The GCF of this 2 is 4, right? So if I factor this guy, I get 4 on the outside. Inside is blank plus blank. So 4 times what will give me 4x? X. 4 times what will give me 8? 2. So when I factor that, that's what I get. So I'm just going to erase this, and I'm going to replace it with 4 times x plus 2. Right? Okay. And x minus 1, can I factor that? No, I can't. So right now I'm just going to circle all my factors just for me to make sure that I don't chop off factors, chopping off arms and legs and whatnot. So I'm going to circle this. Let me just bring this down real quick. Okay, so I'm going to factor that, factor this. I'm sorry, this is a factor, this is a factor, this is a factor, this is a factor, and this is a factor. So when I look at this now, since I'm multiplying, so I'm going to ask myself, well, now I'm going to cancel things or simplify by seeing what does the top have in common with the bottom. So look at this here. What do we see has in common? X minus 3? No. 4? No. X plus 2? Yep. X plus 2 and x plus 2. So if I divide this x plus 2 divided by x plus 2, I just end up getting a 1, right? And that's it. That's the only thing that the top has in common with the bottom. So now that I've simplified, now I can multiply the top, because that's how you multiply fractions. You multiply the top together. So x minus 3 times 4. So I could write 4 times x minus 3. And I don't need to multiply through. I could just leave it as that. The bottom here is x plus 1 times x minus 1. So I could just leave it as that without having to multiply through. And that becomes my final answer. Alrighty, let me unmute you guys. Okay, any questions on what we've done? Pretty clear?
Pretty clear.
All right, let me have you guys try another problem. I want you guys to try in your breakout groups. I want you to go ahead and try number 16. And again, if you don't have the worksheet, I'll write out the problem here. So number 16 here, go ahead and copy down. You don't have the worksheet. 9x squared minus 25 divided by 2x squared plus 3x minus 14 multiplied by 5x minus 10 over 3x plus 5. Okay? So go ahead and try this problem on your own. And then in a second, I'm going to put you guys in breakout groups. All righty, welcome back, everybody. Can you guys all hear me?
Yeah.
Okay, so let's see. So I asked Felicity, I just went into the chat rooms and I asked Felicity to share what she did. So Felicity, you're on.
Okay, okay. Can you guys see it?
Yeah.
Okay. So the first thing I did was right here, the numerator. I did the difference of 2 squares, so I did it right here. And when I did the difference of 2 squares, I got 3x minus 5 and 3x plus 5. So I put that right here.
Okay.
And then at the denominator, I factored it right here. So my factoring work is here. And then when I factored it, I got 2x plus 7 and x minus 2, which is right here. And now for the next one, I got the GCF of 5x minus 10, which is 5. So then when I take out the 5, I'm left with x minus 2. And at the bottom, I didn't factor it. I couldn't find anything or any way to factor it, so I left it as 3x plus 5. And then from then on, I just found what they had in common to cancel out. So they had a 3x plus 5 and a 3x plus 5. I counted that and I got 1. And then I got x minus 2 and x minus 2, counted that out and had 1. And then the leftovers that I had was the 5 from right here, and then 3x minus 5. And at the bottom, I got 2x plus 7 as my answer.
Swear.
Great, nice work, Felicity. Does anyone have any questions for what she did?
Yeah, I have a question for factoring out the bottom part. It's 2x squared plus 3x minus 14.
Yes.
I tried to figure that out, but like I was telling my group, I was confused because I know usually the way I do it is like this, like the number 14, whatever I guess the factors of it are like 7 and 2 are supposed to equal out that middle term, but I don't know if that's like correct or not.
Yeah, so let me see. So can you see this right here? So
a little bit up. Oh, right there. Okay.
Yeah, so this is what I did to factor. So to get 2x squared, you need to multiply 2x and an x, right? And then, like you said, to make 14, I got 7 and 2, but I didn't know which one was going to stay negative, which one was going to stay positive yet. So right here I have, when you cross cancel it, 2x times 2, I got 4x, which is here.
Okay.
And then x plus 7, I got 7x. And then from then, I just asked myself, can I add or subtract these to get a positive 3x? And you can, so I put, it'll only work if the 4 is a negative.
Okay, I see what you did then.
Yeah. And to make it a negative, I just put a negative 2 right here.
Got it. Thank you.
You're welcome.
Very good explanation and very good question. Thank you, Felicity. Any other questions? Any other questions at all from anyone? All right, so I'm going to move us on to dividing polynomials. And the nice thing about dividing polynomials is it's almost exactly the same as multiplying rationals. So here, I'm going to just do a quick review of how do you divide fractions. So when you divide fractions, example, if I had 3/4 divided by 2/7, right? If I was dividing, what do I do first to to change this division sign?
Don't you do the reciprocal of 2/7?
Good. So with 2/7, we switch it to become, and I like the word reciprocal, meaning you flip it upside down. And what does the division sign become?
Multiplication.
Multiplication. Great. Thank you, Anthony. So here, when you do that, then it just becomes a multiplication problem again, right? And then you just do exactly what you've been doing with multiplying. So that's the only difference with dividing and multiplying. You just have one extra step, which is just to change the division to multiplication, and you flip the second fraction, or you take the reciprocal of it. So now let's go ahead and look at a problem that has division for rationals. So I am going to do, how about I'll do number 19. So the hardest one, right? The last problem of this worksheet. Number 19, I have this. All right. All right. So the first thing I see is I see a lot of crazy numbers, but again, stay calm, stay cool. First step you see is division. If I see division, I'm going to change that to multiplication. I'm going to put a dot for multiplication. And what I do with this, I take the second one and I flip it upside down, or in other words, multiply it by its reciprocal. So I get x plus 3 on top. On the bottom, I have 9x squared minus 25. I do not touch the first one. The first one stays as is. So again, the rules of fractions are exactly the same as when you're doing rationals. So now it's multiplication, and now we can approach it like we just did all the multiplication problems that we just did prior to this problem. So if you're multiplying, we don't need a lowest common denominator. We'll only do that when we do adding and subtracting, and we'll get to that on Wednesday. So all I do is I factor everything to death. So I'm going to factor this with you guys. I'll give you guys a moment to go ahead and try factoring it on your own. I'll put it on pause right now, the recording, and then we'll get back to this. All right. Did anyone want to try answering it? Abraham, did you want to try it?
I got 3x plus 1 over 3.
Before you give me the answer, can you just tell me what you did?
All right, my bad.
No worries.
Let me see. All right, so I factored it. So on the top, I got 3. For the left side, I got 3x minus 5.
So the left side, you got 3x minus 5. Okay.
And the parentheses, 3x plus 1.
3x plus 1. Okay, first of all, let me pause there. Does everyone agree with that? Is everyone okay with that?
Yes.
Okay, so Felicita says yes. All righty, then we're moving on then. Go ahead.
And then under, I got 3 parentheses, x plus 3.
All right. Everyone okay with that? Looks like Abraham pulled out the GCF. Everyone good? All right, keep going.
And on the other side, I got, for the bottom part, I got 3x minus 5. And 3x plus 5. And the top, I just left it like that.
Okay. All right, so let's take a look at this. So is this what you got, Abraham? Did I write it down right?
I can't see the bottom one.
Oh, you can't see the bottom? There you go. Is that better?
Yeah.
Okay. All right, any questions, or anyone agree or disagree or have any questions on what Abraham just did? All right, nice work. So what did you do next, Abraham?
I put the same ones together. So 3x minus 5 and then x plus 3.
3x minus 5 and x plus 3?
No, 3x minus 5. I put the same ones, made them into 1. So 3x minus 5 right there.
Uh-huh.
And then the other 3x minus 5.
Oh, I'm sorry. 3x plus 5?
3x minus 5.
5 minus 5. Sorry, okay.
Yeah.
So this becomes a 1. It cancels out to become a 1.
And then x plus 3 with x plus 3.
Okay, x plus 3 and x plus 3 becomes a 1. Good.
And I just multiplied across.
Okay, so you multiply across. 3x plus 1.
over 3 parentheses 3x plus 5.
3x plus 5. All right. Do you guys agree with what Abraham did?
Yes.
Yes.
Does anyone have any questions with what he did?
Let me know.
All right, great job, Abraham. I liked how you Xbox the top here, you pulled the GCF here, you did the difference of 2 squares here, you left this one alone, you knew how to cancel things out, and you multiplied across. So this is using a lot of our factoring skills that we learned in the previous chapter, right? We learned how to do Xbox, GCF, dots, all that stuff, and you're learning how, and you're using the skills of multiplying fractions. So really good job. And I really liked that you did not cancel out the 3's here. So a lot of students, when they get forgetful of this, they see the 3x and the 3x, and they feel tempted to cross it out. So do not do that, because again, this is a whole factor. This is a whole factor. You cannot cancel out pieces of a factor. Again, it's like chopping off an arm from your body, right? Ouch, right? Do not do that to rationals where you chop things off, right? You have to keep them as a whole. All right, nice work, very nice work. Anyone have any questions?
Can I go right now so I can go move my car?
I'm sorry?
I leave right now so I can go move my car?
Go for it, Abraham. Thanks for
see
your help. Thanks for your participation.
All right, see you next meeting.
All right, see you on Wednesday. All righty, and for the rest of you now, do you guys have any other questions? We've covered all the topics. Of course, we didn't do every single thing that's on here, but were there any questions you guys have, or maybe you guys are dying for me to do a problem that's on here, or do you guys feel good? And I'm gonna unmute you guys so I can hear what you guys are saying. Everyone good? Any questions?
Yes. You explained it pretty well.
Okay.
It's good. And we have I'm not sure if everybody has it, but there's a answer sheet on the back. So I guess that's really cool. We could check our answers if we need to.
Oh, that's right. You just have the answer key in the back.
Yeah.
Great. Thanks for reminding us of that, Jessica.
Yeah.
Yes, there's an answer key back there.
Don't accidentally do that for the test.
The answer key will not be part of the test. So when is this due, everyone? Thursday. Right, there's 19 questions, so please make sure you do this. Actually, if you can, try to do it before Wednesday, because by Wednesday we're going to get to part B, and part B is going to have to do with adding and subtracting, and that's going to be a lot harder, because as you know, when we add and subtract fractions, you need a lowest common denominator, and it's really a lot more challenging. So if you can get this out of the way and get it under your belt, you'll be in better shape for Wednesday's lecture. Alrighty. What time is it now? It's 12:33. I'm going to stay on for a little bit longer if anyone has any questions. If I can leave you on for just a little bit longer, if you don't mind. If the rest of you guys, if you guys need to go now, feel free. Thank you for joining me. It was good to see you guys. I'll see you guys on Wednesday at 1 o'clock if you guys can make it.
All right.
Bye.
Thank you.
Mwah. Hey Garrett, are you there?
Yeah.
Okay, let me. So I think maybe in the future, I love that you were part of the breakout groups. So you were able to help out one group and also able to help out the other group.
Mm-hmm.
Maybe in the future or in future sessions, I'll continue to do that, and I'll put maybe a larger group with you so that you could help more people at the same time. Is that good?
Yeah, that was fine. Yeah, and I was able to like kind of explain some of the details. A lot of them were mixed up with the opposite thing with like x minus 1 over 1 minus x, and so I clarified that for a handful of people. This
Good.
thing. That
Do you
thing.
have a whiteboard? Oh yeah, that. Oh, you do have your whiteboard.
Yeah.
Good. I'm glad.
And I just showed them like all the examples, and it's like just specifically this one where you're illustrating it, and they're just kind of they're unsure of which ones. They were thinking maybe if this was like a plus sign, I could do it, and I just said no, only when they're opposite or the same sign.
Mm.
And I